Section 555.13a permits the use of flexible cables, specifically types G, PP, and W, as a wiring method on docks. However, the electrical code doesn't explicitly define how far these cables can extend beyond the water's edge while still maintaining compliance. Let's consider two scenarios. Firstly, extending the cable under a ramp, then over a bulkhead, and laying it on the ground along a wooden walkway to a panel or junction box is generally not compliant. When not over water, the cable should be installed in a protected location such as a conduit. Secondly, running the cable through a conduit after it leaves the dock and continuing the conduit to the panel or junction box is a compliant method. Now let's delve into the ampacity rating of Type W cable. Table 400.5b provides ampacity ratings for flexible cords and cables. It's important to note the wording connected to utilization equipment. Utilization equipment refers to equipment that consumes electrical energy to perform a specific task. This includes devices like motors, lighting fixtures, and electrical appliances. In the context of a marina power center, if the Type W cable is connected to a power center that contains circuit breakers, receptacles, and lights, the power center is considered utilization equipment. This allows for the use of the ampacity ratings specified in column E, which is the 75 degrees Celsius column of Table 400.5b for sizing the overcurrent protection. Therefore, to summarize, flexible cables types G, PP, and W should not extend beyond protected areas after leaving the dock area unless installed in a raceway. When Type W cable is connected to utilization equipment, such as a marina power center, the ampacity ratings in column E, 75 degrees Celsius, of Table 400.5b can be used for sizing the overcurrent protection. The notes within Table 400.5b are crucial for understanding the application of these ampacity ratings. Understanding what constitutes utilization equipment is key. The electrical code defines utilization equipment as equipment that utilizes electrical energy for electronic, electromechanical, chemical, heating, lighting, or similar purposes. This definition is broad and encompasses a wide range of devices. Therefore, any equipment drawing electrical power to perform a task is likely to fall under this category. Overcurrent protection is a critical safety component in electrical systems. It protects the wiring and equipment from damage due to excessive current flow, which can result from overloads or short circuits. Sizing the overcurrent protection appropriately ensures that the circuit breaker or fuse will trip and interrupt the current flow before damage occurs. When using the ampacity ratings from Table 400.5b, it is crucial to select the correct column based on the cable's temperature rating and the termination temperature rating of the connected equipment. The 75 degrees Celsius column is commonly used, but it is essential to verify that all components in the circuit are rated for at least this temperature. Additionally, any relevant directing factors must be applied to the ampacity ratings. Directing factors are used to adjust the ampacity of a conductor when it is installed in conditions that reduce its ability to dissipate heat. Common directing factors include ambient temperature correction and conductor bundling. For example, if a cable is installed in a hot environment or bundled with other conductors, its ampacity must be reduced accordingly. Ensuring proper installation of flexible cables is vital for safety and compliance. Cables should be supported properly and protected from physical damage. When running cables through conduit, use appropriate fittings and ensure that the conduit is properly sized to accommodate the cables. Additionally, avoid exceeding the maximum fill capacity of the conduit, as this can lead to overheating and damage. Also, always consult local electrical codes and regulations. Local jurisdictions may have additional requirements or restrictions on the use of flexible cables. It is important to be aware of these requirements and to comply with them. In general, wiring installed over or near water needs to be protected against corrosion. Special consideration should be given to the type of materials used. Stainless steel and certain types of coated copper wiring are resistant to corrosion. Check local and national codes to ensure that you are up to compliance. The National Electrical Code, or NEC, is a set of guidelines that are widely adopted. The NEC is updated every 3 years, so it's important to have the latest version to ensure compliance. Some of the relevant sections for marina wiring include Article 555 covering marinas and boatyards, Article 400 covering flexible cords and cables, and Article 310 covering conductors for general wiring. These articles provide specific requirements for wiring methods, conductor sizing, overcurrent protection, and grounding. Grounding is another critical aspect of electrical safety, particularly in wet environments. Proper grounding ensures that any fault current will safely return to the source, tripping the overcurrent protection and preventing electrical shock hazards. Marinas and boatyards often have specific grounding requirements due to the presence of water and the potential for stray currents. It's also important to regularly inspect and maintain electrical systems in marinas and boatyards. This includes checking for damaged wiring, loose connections, and corroded components. Regular maintenance can help identify and correct potential hazards before they cause problems. If any issues are found, they should be addressed promptly by a qualified electrician. Furthermore, surge protection devices can help protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. Surge protection is especially important in marinas, where electrical equipment is often exposed to the elements. The selection and installation of surge protection devices should be done in accordance with the manufacturer's instructions and the electrical code. Furthermore, ground fault circuit interrupters, or GFCIs, are required in many locations in marinas and boatyards. GFCIs are designed to detect small ground faults and interrupt the circuit quickly, preventing electrical shock. GFCIs should be tested regularly to ensure that they are functioning properly. The proper selection and installation of electrical equipment is critical for safety and reliability. Electrical equipment used in marinas and boatyards should be suitable for wet locations and resistant to corrosion. This includes enclosures, wiring devices, and lighting fixtures. Equipment should be installed in accordance with the manufacturer's instructions and the electrical code. Also, proper signage should be installed to warn people of potential electrical hazards. This includes signs indicating the location of electrical panels, the presence of GFCIs, and warnings about the dangers of electrical shock. Signage should be clear, concise, and easily visible. In addition to the technical aspects of electrical installations, it is also important to educate boat owners and marina users about electrical safety. This includes providing information on the dangers of electrical shock, the importance of GFCIs, and how to identify and report electrical hazards. Education can help prevent accidents and ensure the safety of everyone in the marina. Electrical systems in marinas and boatyards are subject to harsh environmental conditions, including exposure to salt water, sunlight, and extreme temperatures. These conditions can accelerate the deterioration of electrical components and increase the risk of failures. Regular inspection and maintenance are essential to identify and correct potential problems before they lead to accidents. When performing electrical work in marinas and boatyards, it is important to follow safe work practices. This includes energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. Additionally, it is important to be aware of the potential for stray currents in the water and to take precautions to avoid electrical shock. Also, consider using underwater lighting. Underwater lighting can enhance the beauty and safety of marinas and boatyards. However, underwater lighting installations must be done in accordance with the electrical code and the manufacturer's instructions. This includes using submersible lighting fixtures, providing proper grounding, and installing GFCIs. Marina power distribution systems are designed to provide electrical power to boats and other equipment in the marina. These systems typically include transformers, switchgear, panel boards, and wiring. The design and installation of marina power distribution systems must be done in accordance with the electrical code and the utility company's requirements. Furthermore, emergency power systems are essential for maintaining critical functions during power outages. Emergency power systems can provide backup power for lighting, navigation aids, and other essential equipment. The design and installation of emergency power systems must be done in accordance with the electrical code and applicable standards. Also, electrical load calculations are necessary to determine the size of electrical equipment and wiring. Load calculations must take into account the connected load, the demand factor, and the diversity factor. The electrical code provides guidelines for performing load calculations. And also, voltage drop calculations are necessary to ensure that voltage of the load is within acceptable limits. Excessive voltage drop can cause equipment to malfunction or fail. The electrical code provides guidelines for performing voltage drop calculations. Coordination studies are performed to ensure that overcurrent protection devices are properly coordinated. Coordination studies help prevent nuisance tripping and ensure that the electrical system is protected from faults. In addition, arc flash studies are performed to determine the potential for arc flash hazards. Arc flash studies help identify areas where arc flash protection is needed and determine the appropriate level of protection. Review the labeling of electrical equipment. Electrical equipment must be properly labeled to provide information about its voltage, current, and other characteristics. Labeling helps ensure that equipment is installed and used correctly. Also, testing and commissioning are performed to verify that the electrical system is functioning properly. Testing and commissioning include insulation resistance testing, continuity testing, and ground impedance testing. Review safety training. Safety training should be provided to all personnel who work on or near electrical equipment. Safety training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. The design and installation of electrical systems in marinas and boatyards are complex and require specialized knowledge and experience. It is important to consult with a qualified electrical engineer and a licensed electrical contractor to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. Lastly, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that electrical systems are safe and compliant. Changes in technology and industry practices often lead to revisions in codes and standards. So it's best to be on the lookout.